The fuel pressure regulator or suction control valve plays a vital role in diesel engines. If the valve or circuit was to fault, what should we check for? And what are the steps needed to resolve the problem? G'day, I'm Zach. Welcome to Automate. The suction control valve works in a closed loop system with a fuel rail pressure sensor, ECM and injectors. The valve relies on feedback from the rail pressure sensor in order to supply the correct amount of fuel required to keep the rail at its working pressure. The suction control valve regulates the amount of fuel entering the pumping chambers to meet all engine load conditions. The valve receives a duty cycle control from the ECM in order to allow more or less fuel into the pumping chambers. The ECM monitors the fuel rail pressure sensor and suction control valve to determine if the commanded and actual pressures are within a predetermined range. If they fall outside the desired parameters for a predetermined time, a P0091 DTC may set. Always consult the freeze frame failure records for a more detailed overview of the running conditions at the time of the fault. It's not uncommon for other fuel pressure related DTCs to set as a result of the P0091, such as fuel rail pressure high and low. For a more detailed description of these systems, please view our other in-depth diesel training modules. A quick test to perform before condemning the suction control valve, ECM or harness is to confirm the connector is attached to the fuel pressure regulator. Look for any signs of damage to the harness or the connector retaining tab. Next, using a digital multimeter, attach the red meter lead to the ignition supply terminal and the black to the low side control. Now using a scan tool, turn the ignition on and command the regulator on, then off while watching the meter. Ignition voltage should be seen when commanding the regulator on and 0 volts when off. If this test was okay, the only fault would be the control valve itself. If ignition voltage wasn't seen, there may be a short to ground, open or excess resistance in the circuit. To test for a short to ground on this circuit, turn the ignition off and place the red lead to battery positive and the black attached to the ignition control terminal. Turn the ignition back on. Any voltage now displayed on the meter will confirm a short to ground within the circuit. If there is another connector in line, disconnect it while watching the meter. If voltage is still present, the short to ground is within the first section of the harness. However, if the voltage dropped to 0, the short is in the second section of the harness or the ECM. Turn the ignition off and move the black meter lead to this connector and then disconnect the ECM harness connector. Turn the ignition back on while watching the display. If the meter displays any voltage now, then the short has been localized to this next section of harness. But if the meter displayed 0 volts, then the short to ground might be in the ECM or a circuit from the ECM. To differentiate, perform a continuity test between the ignition control terminal and all other terminals in that connector. If no fault is found, the short to ground is within the ECM. Connect the black meter lead to battery negative and the red to ignition control terminal in the harness connector. Turn the ignition on. If the meter displays less than ignition or 0 volts, there may be excess resistance or an open within the circuit. Move the red lead to the next inline connector and retest. If the correct voltage is now seen, this confirms an open or excess resistance within this section of the harness. Check the inline harness connector for terminal tension and corrosion. If this is okay, the fault is within the harness between the two connectors. However, if the meter still displayed 0 volts, using the red lead, back probe the ignition control terminal at the ECM connector while observing the display. If the correct voltage is now seen, this confirms the excess resistance or open to be within the next section of the wiring harness. But if the meter still displayed 0 volts, turn the ignition off, disconnect the ECM harness connector and check for terminal tension and corrosion. If this is okay, the fault is within the ECM. With the ignition off and the regulator valve harness disconnected, attach the black meter lead to the low side control terminal and the red to battery positive. Turn the ignition on and watch the meter. Any voltage now displayed will confirm a short to ground. Disconnect the inline connector while observing the meter. If voltage is still present, the short has been localised to this first section of harness. However, if the value dropped to 0, move the black meter lead to the inline harness connector low side terminal. Turn the ignition off and disconnect the ECM. If voltage is still present with the ECM harness disconnected, this narrows the short to this next section of harness. Although, if the voltage dropped to 0, the short to ground might be in the ECM or a circuit from the ECM. To differentiate, perform a continuity test between the low side control terminal and all other terminals in the ECM connector. If no fault is found, the short must be within the ECM. These are the tests required to successfully address and diagnose a P0091 circuit fault. It's imperative that you're methodical in your approach to diagnostics. Thanks for watching. See you soon.